Hey guys, Mr. Champlin here. Going to show you how to solve the sample conservation of mechanical energy problem. So the problem says, starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is her speed at the bottom of the slide? Assume she has a mass of 25 kilograms. So first of all, let's write down what we know. So the initial height is 3 meters. So h is 3 meters. Mass, we know that, 25 kilograms. And we know also g, of course, the acceleration of gravity, 9.81. All right, so it seems like we don't have a lot of information. So how are we going to solve this? So now remember that the formula for conservation of energy is the initial kinetic energy plus the initial potential energy, which in this case, of course, is going to be gravitational potential energy because she's falling. She's essentially falling down a slide. That is equal to the final kinetic energy plus the final GPE. So again, not much information, so how is this all going to work out? Well, again, if we look at the problem, it says starting from rest. So if she's starting from rest, what is the initial kinetic energy of this child? Well, the answer is 0. So she's not moving, so therefore her initial kinetic energy is 0. So we don't have to even worry about that. Likewise, when she gets to the bottom of the slide, what is her final gravitational potential energy? Well, again, the answer is 0. She's at the bottom of the slide. She can't fall anymore. So that gets rid of that. So essentially, what we have here is the gravitational potential energy is equal to the final kinetic energy. So remember that the formula for GPE is going to be mgh. Remember the formula for Ke is going to be 1/2 mv squared. So it's just going to be simply mgh. So let's plug it in. Actually, no, let's write it out first. Mgh is equal to 1/2 mv squared. So let's plug in things now. So we know that the mass is going to be 25. We know that g is 9.8. Let's round it off. And we know the height is going to be 3. So we know that is equal to 1/2. Oop, I forgot mv squared here. I forgot the m. The mass, which is going to be 25, and v squared, we don't know, right? So that's the final velocity. We should probably make that final velocity. So let's simplify this to find our final velocity. Grab my calculator here. All right, so this side's easy to simplify. It's simply 25 times 9.8 times 3, which we get 735. So 735 is equal to 1/2 25 VF squared. 1/2 of 25, I believe it's 12.5, but let me just double check that. Yep. So 735 is equal to 12.5 VF squared. We want to get rid of this 12.5, so we simply have to divide by 12.5 on both sides. So that will get rid of it on the right. Then we have to divide 735 divided by 12.5, which is 58.8, is equal to VF squared. Now, of course, the very last thing we have to do is find the square root of VF and find the square root on this side. So the square root of VF is obviously going to be VF. The square root of 58.8 is 7.69. And of course, that's going to be meters per second. So there we go. That's our answer, 7.69 meters per second. So again, it looks really complicated, the formula, but in reality, in most or all cases, you're going to be able to simplify it quite a bit. Now, also, I want to mention too that a little bit later we're going to be talking about momentum, and you're going to see kind of this same sort of concept in that the initial momentum is going to be equal to the final momentum, and the formula is going to look very, very similar. It's going to have the same kind of setup. Now, again, we can also, we talked about gravitational potential energy in this particular problem, but we could also, this could be elastic potential energy, which in that case, you just simply use the elastic potential energy formula instead of the GPE formula. But the concept is really just the same. So I know this is a little bit more difficult than we've done in the past month or so, but I'm sure you guys can handle it. If you have any questions, make sure that you post it on Teams, or that you send us a message. All right, I hope that's helpful.